If you can solve an equation, you can solve an inequality because they're the exact same thing. The only difference is it's going to have an inequality symbol instead of an equal sign. All right, now, one thing that we didn't do when we solved the equations. All right, let's go back and look at our equations. We had like x plus 4 equals 10. All right, and then what did we do? We solved them, so that was just a one step. So what? We subtract 4 from both sides. So you did minus 4, you did minus 4. And then what? X equals 6. And then that's all we did, right? We just found the one answer that makes the equation true. There was no reason to graph that answer because it's one and only one answer. Could we have graphed that on a number line? Yeah, we could have. All right, if we would have graphed it, then we would have our traditional number line. Our answer was 6, so we would put that probably in the middle of the number line, because if the answer would have been 200, you don't want to start at 0 and make 200 hash marks. So whatever answer that is goes in the middle of the number line. What numbers go to the right? Positive ones that are bigger. So then a 7 would go over here, and a 5 would go over here. And if we would have graphed that, we would have just put a closed dot on the 6, because that's the only answer that makes that equation true. All right, so now we're going to do inequalities. So instead of having this, we might have, I'll do the same numbers, x plus 4, but then maybe less than 10. So the only thing that's going to be different is that symbol right there. If you can solve it with an equal sign, you can solve it with an inequality because you do it the exact same way. You isolate your x. So what are we going to do to both sides? We're going to subtract our 4 just like we did before. That x is going to come down. Now, the answer is going to change in the sense that it's an inequality symbol, but 10 minus 4 is still 6. All right, now, how many answers make this one true? 2. Is there more than 2?
More?
Yeah, more. Lots. Tons. Anything, Jackson's doing this with his hand, anything less than 6. All right, so now, yes, this is our answer, but to really show it and visualize it, we're still going to put 6 in the middle of the number line. We're going to put 7 over here. We're going to put 5 here. All right, all of these numbers that are anything that's less than 6 makes this true. So I could put in a 2. I could put in a 5. I could put in a 6. I could put in a negative 3. All right, so now here, my question is, can I put 6 in and make it true?
Mm-hmm. No.
No, because then 6 is not less than 6. Okay, so since I cannot include the 6, it gets an open dot. And then I am going to shade. Now, in middle school, you might have been taught to shade above the number line, that sort of thing. I don't want you to do that. I want you shading right on the number line. Okay, I can read it. We can clearly see this is shaded. You can make this a little bit fatter and bigger than that down there so we can clearly see. Now, today in the directions, what some of the questions are going to say, solve, that's this part, and graph. All right, if it just says solve, then all you have to do is solve. But if it says solve and graph, then you got to do the number line with it. Okay? Now, some general information. We got to decide whether or not, or I'm going to give you a way to decide what type of dot it is. All right? If it is a less than or a greater than symbol, which we had here, was less than, it means we're never going to include the number, so it's always going to be an open dot. I call that an open dot. We're going to put an open dot on the number, all right, because it's just a plain less than or greater than, so you're going to want to memorize that. If it is less than or equal to, greater than or equal to, if it's got the equal to, it's closed, because if that said x is less than or equal to 6, then the 6 would have worked. So then we're going to call that a closed dot. All right, and your closed dots look just like that. So you can have closed dots on the end of these graphs. You can have open dots on the end of these graphs. And you should have done these in middle school. Okay? Now, they're going to start you out not just with the solving, because you can do a lot of other things. they could just give you this and ask you to graph. They could give you the number line and ask you to write the inequality. Then they could give you an equation with distributive property, x on both sides, combining like terms. It can be as complicated as we need it to be, and it can be on both sides, and then ask you to solve it and then graph it. Okay, so let's take a look at some of the examples of what you're going to see. Okay, let's say it says graph, and then let's say we've got x is greater than or equal to 4. And I'll put my answers in a different color here. All right, so if it tells you to graph, then you are drawing a little miniature number line. All right, no matter what that number is, put that number in the middle, okay? Because, again, we don't want to start at 0 and make tons of hash marks, because that number could be 100. That number could be 200. All right, so whatever that number is, put it in the middle. I do want 2 numbers on both sides, because I want to know you know how to draw a number line. What number goes on the right? 5. What number goes on the left? 3. Okay, then you're going to come up here and you're going to look at that symbol. Do I need an open dot or a closed dot? Closed dot. Now, this is where it's going to be really important. Can you read that inequality symbol? That says x is greater than or equal to 4. So, are the numbers on the right greater than or the ones on the left? Right. The ones on the right. So then you shade this way. So make in a great big arrow and shade that way. Okay, so pretty straightforward. If you can graph it, then you ought to be able to write the inequality if they give you the graph. All right, so a second type of question you might see, it might say write the inequality. And then they draw the picture of the number line. Obviously, in your book, this would already be all drawn out. The reason we have to draw the whole question out here in our notes is so that we can see it. All right, but in your textbook, you would see the picture of the graph. You would see the directions that said write the inequality. All right, now I'm going to suggest that the first thing you write down on your paper is always the x. All right, we're all going to use x. We don't use different variables. All right, now, whatever number the dot is on, that's the number that goes down, so write that number down. I would write those two things down first. Okay, now, over here is where it's shaded. Are these numbers less than or greater than? Less than. So that tells you what symbol to put in the middle. Less than. Now, you look at the dot. Do I need the equal to part? No. So then I'm done. And then, so that's always how I would do it. Start with the x, then put the number down, and then just ask yourself, are the ones that are shaded less than the number, or are the ones that are shaded greater than? Okay, so that should be pretty straightforward. All right, good so far? Thumbs up. Pretty easy. Okay, now let's go to a little bit more complicated one here. Let's suppose the directions say solve and then graph. Solve and graph. Now, honestly, in today's assignment, I think they're just going to be one-step equations, but they could be two-step. They could have distributive. They could have combining like terms. All right, so let's suppose we had something like an x minus a 3 is, and see what did I start to do? I started to write an equal sign. Greater than or equal to a negative 12. All right, it's going to be your one-step equations. We know how to do this. What are we going to do to both sides? Plus 3. So I'm going to do plus 3 plus 3. All right. Now, the number one common mistake, what you're going to do, you're going to do the plus 3 just fine. You'll write down the x just fine. You'll even do the number over here on the right just fine. But then what you're going to forget is you're going to forget the inequality symbol and you're going to accidentally put an equal sign in there. I mean, that's just the common mistake. So just always look up, keep that same sign there, and then we're going to have a -9. So that's the solve part of it. When you do the algebra steps that we've been doing for the past month or so, all right, that's the solve part. All right, then you have to graph it. What number is going to go in the middle of the number line? -9. All right, what number goes to the right? Ooh, -8, because we got to get bigger when we go to the right. We've got to get smaller when we go to the left. So that makes a -10 here. All right, I will check those two numbers. You got to make sure you put the numbers on the right side. Okay, now, solid dot or open dot? Solid dot, closed dot, because of the equal to part, so closed dot. All right, now, again, you got to be able to read that symbol. X is greater than -9. So which side? To the right. All right, because the inequalities are so easy, and because we've spent several weeks solving one-step equations as well as more complicated ones, okay, then this chapter should go very, very easily here. Now, I do want to do a more complicated one, and I want it to not come out to an integer. Every one of these that I've done so far has been -9, 10, -2. They're all integers. They don't have to be integers because we've done mixed numbers before. All right, so let's do one more where it says solve and graph. And this one will not come out even because I want to show you what it's going to look like on your graph. Okay, so solve and then graph. All right, let's do like a 2 parentheses 3x minus 1 plus 5 less than -10. Say what? Okay. All right, so what are we going to do first? Yep, solve those parentheses, which is the distributive property. So you're going to distribute the 2. All right, 2 times 3, 6x. 2 times the 1, -2. And then I'm just going to bring down everything else. I'm going to bring down the plus 5 is less than a -10. All right, we've got some like terms that we can put together over here. -2 plus 5, 3. So I'm going to have a 6x plus a 3 is less than -10. And these are the kind, really seriously, where that you might accidentally forget and start putting your equal signs in. Okay, now that just looks like a 2-step equation, right? So -3 from both sides. So then we'll have a 6x, and then keeping that inequality symbol. Let's see, -13? Yeah, see, I told you. Putting that equal sign happens. I even do it a lot. All right, now, do you remember how we did these? We turned them into mixed numbers, right? So we know the overall answer is going to be negative because they're unlike signs. So x is less than, I know it's going to be negative. 6 goes into 13 how many times? Twice, which is 12. So how many would be left over? 1. And then 6 for the bottom. And that's okay. We'd have answers like that. Now, the thing is, when you put that on your number line, it's not going to be on a hash mark. Henry? Well, except 1, 6 is not 0.5. And I just like the mixed numbers. Because in that way, everybody in the room's got the exact same answer. Not that we can't. Now, tell me this. -2 and 1, 6 is in between what two numbers? -2 and -3. -2 and 1, 6 is just a smudgy bit past -2. And you got to think, because it's negative, so you got to think opposite here. So I'm going to draw my number line up here just so I've got more room. So I'm going to put, yeah, I do get crazy with my number line sometimes. There's a -2. The -3 would be to the left. All right, and so I don't have a single number that I put in the center because this one is in between two numbers. So if you have a mixed number that's in between, put both of the two numbers that it's in between. Now, is negative 2 and 1/6 going to be closer to the negative 2 or closer to the negative 3? Ooh, negative 2, because it's 1/6. All right, if it would have been 5/6, it would have been closer to the negative 3. So I'm going to estimate about where it's at. Now, do I need an open dot or closed dot? Open dot. So I'm just going to estimate it. We don't need to be precise. I'm going to estimate it. So there's my estimate right there. All right, now, x is less than. Where are the numbers that are less than this spot?
Left.
Left, always left. Less than is always left. The numbers on the number line are going to the left, they're less than. Going to the right, they're bigger. Now, if you would want to do negative 2 and 1/6, you could do that. I'm not going to put a hash mark on there. Hash marks are reserved for the integers. Hash marks are reserved for the integers, and negative 2 and 1/6 is not an integer. So if by chance you end up with some type of mixed number, then graph it in between the two numbers that it falls.